moderating these evenings, but today I have a technical topic prepared for you. It's about designing APIs on top of data platforms using Databricks. Designing APIs on top of data platforms. By saying that, the core idea is to serve the data from a lakehouse through APIs without owning the data storage layer. And not owning the data is more and more the case if you think about data mesh principles, for example. I prepared the solution architecture for you, and also we'll talk about the data flow, the data processing, and of course also talk about our challenges. Let's first think about why do we need this? Designing APIs directly on top of data platforms provides a modern approach to expose enterprise data products. With that, we maintain scalability, governance, and data ownership. Regarding the data sources, you can handle a mix of data silos, legacy data systems, and modern data architectures. Without owning the storage, you have challenges, of course, but you avoid data duplication and keep the data source as simple source of truth. You keep a clear separation of responsibilities. The API layer focuses on exposing standardized interfaces to consumers. And you keep the domain ownership on the side of the domain teams. So, our main use case. For us, it is the EU Data Act. It's a law from the European Union. So let's shortly get interactive. I have two questions for you. The first one is about who owns a car? Please raise your hand. Yeah, maybe around the half or something. And who gave consent for data collection? So in other words, who has a digital profile for his car? Two, actually. Interesting. I don't. So, okay, nice to know. Coming back to the EU Data Act. The EU Data Act says each IoT device owner has the legal right to access data which was sent to the cloud. The car is nowadays also an IoT device. The vehicles are connected and they are sent permanently data which must be accessible by the vehicle owners. This includes, for example, vehicle health, location, speed, driving patterns, and many more. So let's have a look at the solution architecture. Our data processing component is called Jolly Brown. On the left here, we have the API caller, which is the customer portal. It's a front end. And Jolly consists of an API part and the data processing part here. And of course, on the right side, you have the data sources. And this is the final storage. It's basically the delivery storage where the customer portal is again grabbing the prepared data. Jolly provides a unified API for requesting data from multiple sources. Jolly delivers a standardized format. It's a JSON format packaged as a zip file. The design follows several key principles. Event processing, event-driven processing. No redundant storage of business data. Scalability, scalable data retrieval through Databricks, standardized data provisioning, and you decouple the ingestion from the delivery. Within the further slides, I will lead you through the components here. So, coming to the data flow, let's have a deeper look on the processing of Jolly Brown. So the process begins here when the customer portal sends a request to the receiver API. The request is received by this one. This is a Azure function, and basically the request delivers accepted, while the actual data retrieval continuously continues asynchronously in the background further. And at the center of the solution here we have Databricks, which orchestrates the retrieval from multiple data sources and transform the information into a common delivery format then. And finally, the zip is provided. About the data source ingestion. Assume there is a legacy data source which does not have the preconditions to connect to Jolly Brown. Basically, it means that the data must be first collected and prepared before it becomes available for the retrieval. Therefore, we have a component which is called the source adapter. The request is forwarded to the data source adapter, which is responsible for initiating the ingestion. It triggers the process and writes the resulting data into a short-term storage component. It's here. And the adapter publishes a notification message to the Azure Service Bus here. And this event-driven approach decouples the ingestion from processing. Next to the legacy data sources, there are also, of course, other data sources. They are using the Unity Catalog integration, where we have a catalog per data source. This catalog provides logical access to the source system, to the underlying storage location. The processing job never accesses the storage directly. Instead, the query of the external tables of the Unity Catalog. This creates a clean separation between the physical storage and the processing logic. A key design principle is that the platform does not duplicate the source data. The external table layer allows Databricks to query the data without creating additional copies. Coming to the data governance. So it's policy-based data filtering with Collibra. When exposing data through APIs, it is essential that the consumers only receive data they are authorized to access. The API does not decide which data is visible. The governance layer does. Collibra, a data catalog, defines which data is allowed to share, while the Databricks enforces these policies during the data processing. And the governance ensures compliance with legal and business-specific sharing policies, like, for example, which vehicle is authorized. Also, in terms of personal and sensitive data, which data needs to be filtered, and the legal restrictions, of course, like the EU Data Act or the GDPR. So we talked about the surroundings of Jolly Brown, and now let's come to Databricks, which is the center of the solution. So basically there's a job. This one here is the orchestrator with the following responsibilities. It listens to the service bus and checks for completed ingestion messages here. It determines which data source must be collected. And it creates a processing job. So when a new event is detected, the orchestrator starts a dedicated job. And the orchestrator itself does not perform the data transformation, the work is delegated. Coming to the data retrieval itself. So this is a screenshot of a pipeline run in Databricks, and you see the different tasks here. And basically the data sources are collected from multiple sources in parallel. So the parallel retrieval significantly reduces the processing time. And the job reads newly ingested data from the short-term storage, existing data from all other data sources, and based on the core parameter, the data sources are requested by batches of wins which is the vehicle ID of the cars. A job cluster is used where a dedicated cluster from a cluster pool is started per job. So, coming to our challenges. Balancing performance, data structures and costs. Of course, performance was and is still a topic. So the Databricks cluster size directly impacts the processing time and the throughput. Also, parallel processing is very important. And the cluster startup time influences the job latency very much. So if you use a job cluster and the job is starting, also the cluster needs to be prepared. Then thinking about the data structures. The storage layout has a major impact on the query performance. If you, for example, have a Delta Lake, which is optimal for data retrieval, or if you have plain parquet, this is a quite big impact. So some of our data sources using plain parquet, and we also ran in the small file problem. Basically, you might know, this is where Spark needs to be scan millions of small data chunks if needed. And regarding the costs, of course, larger clusters improve the performance, but increase the costs a lot. And on the other hand, efficient data organization reduces the runtime and lowers the costs. Yeah, in sum, there needs to be always a balance between these three things here. So, coming to the final slide, the key takeaways. At the beginning, we had the question about how to serve data from a lakehouse through APIs without owning the data storage layer. And I think you learned today that designing APIs on top of data lakehouses is not only an API design problem. It's also, of course, a data engineering challenge and a platform engineering challenge. And in regards of avoiding data duplication, as a hint, it is common to keep the single source of truth on the data source side, but having derived automatically refreshed structures like indices, materialized views, caches or lookup tables. These things, with the purpose to make queries efficient, these copies are fine to use. They are not changing the data ownership. Okay. So finally, thank you very much. Do you have any questions?